Okay. Um. So. Um. Hello. Hello. As you can see on the screen. Hmm. Hello. Hello. Today I'm going to continue with this problem or instance. Um. I divided the instance into two instances. Instance. Um. I will talk more about this. Um, as you can see, I try to um, ask ChatGPT about this instance, and it gave me some answers. And I try to keep asking what's going on, what's the problem that I encountered. There are a lot of interesting insights that I will show you in this video. I will give you a quick sneak peek on what I'm going to tell you. Of course, there are some things that can't. There are some things on which I can't really trust ChatGPT 100%. But I see most of the times in this case that it is really good. Like it gave me good answers, um, and yeah, just good reasoning, which can be a bit dangerous. Not really dangerous or harmful, but in dangerous I mean that it can lie about it. But yeah, I'm going to talk about this. So in some previous videos, I can go to here. Like in this video, I tried to solve this problem, but it didn't really work out because there are some things like I did not really formulate my problem really good, which causes me to doubt what is going on, or if the method is really working or not. Um, so yeah, I'm not going to stall any further. I'm just going to read this, and yeah, I have an assignment problem, operation research. That's the topic, and I need to solve this instance. Machine 1 and 3 can do at most 2 tasks. Machine 2 can do at most 1 task. Here's the cost duration list. Machine 1 for task 1 cost 10 minutes, and for task 3 it cost 6 minutes. But machine 1 can't do task 2. Machine 2 can do task 1, but for task 2 and 3 it costs 20 and 11 minutes respectively. This means task 2 costs 20 minutes, task 3 costs 11 minutes. Then to the third machine. Machine 3 can't do task 3, but for task 1 and 2 it costs 14 and 20 minutes respectively. Again, task 1 costs 40 minutes and task 2 costs 21 minutes. I want to find the optimal solution, minimal cost duration, for this assignment. Can you spot some problems in my formulation and also find the optimal solution? Why did I say this? Because I had some feeling that my formulation causes the problem that I had in my in this video, which can lead to a lot of different answers, and this might cause some problems, like which answer is for which instance, good or bad. So yeah, that's why I added this in my prompt, and yeah, I will continue. Again, if you hear me, I don't like to delay stuff, but I try to say more, add things more. In my mind, it's empty, and I try to find something in my mind if I can add more. That's why I have like some delay. I try to find some words. Again, this is not intentional, and yeah, it is quite a bit of a problem. So yeah, I keep saying yeah, it is also a bit of an issue. Yeah, sorry. I will continue. Not giving up. Okay, this is what ChatGPT says. Nice. This is a small, neat assignment problem. I will point out common formulation mistakes you might have. 2. Give a clear integer program formulation, and 3. Solve it and show the optimal assignment with total duration. Yes, so there are 3 things that I didn't do in my last video, in this video, and I will try do this in GIMP. 1 second. So I'm in GIMP. I will make a new what's called new image, and I will add this. Oh wait, what? It copied some something from ChatGPT. Okay, that's not good. Can I Ctrl C? Okay. This is not good. I see Ctrl N. I will just press Ctrl N, use my keyboard, replace this. This is 3.0.6 revision 1, and the background color, that is black. I will not use my middle mouse, otherwise it might change some settings. So I will use this scroll bar, if you are wondering, and I will press OK. Then I will add a new layer. I will leave the, I won't choose a color, I will just press this, layer 1. A bit of a disclaimer, this video might be a bit long, so please be patient. Please be patient with me, because there's a lot of things that I like to talk about. This is also a bit of a learning experience for me. Also, there are children screaming and playing around outside, which is a bit weird. Okay, the LP formulation. LP formulation. It's a bit annoying. Wait, I will make the table first, because it will make the formulation somewhat easier. So for now, if I sorry, if I say mi, this means machine E, and if I say task G, that means task G. I and G are integers. In this case, I and G are, I think this. I don't know how to say this. I can be 1, 2 or 3, and G can be 1, 2 or 3. This is a bit unnecessary, to be honest, so this is okay. Can I go to the left? Oh yeah, I forgot. Disk, and then machine. One, 2, and 3. 1, 2, and 3. Machine 1 for task 1 costs 10 minutes, and for task 3 6 minutes. But machine 1 can do task 2, so I will place a dash for now. Machine 2 can do task 1, so machine 1 can't do task 1, but machine 2 can do what am I saying? Machine 2 can either do task 2 or 3. In this case, task 2 and 3 cost 20 and 11 minutes respectively. Machine 3 can do task 3. This is gone, and this cost 40 minutes, and this cost 21 minutes. And yeah. I will talk more about these dashes later. But for now, I will continue with the formulation. If you're wondering what is LP, LP means... Oh wait, wrong layer. Yeah, so LP means linear programming, or I mean linear problem. Wait, is it linear programming or linear problem? I think linear programming, linear program. Yeah, I think. Oh no, this is really bad. If I don't know this, then that can give me some issues later. If I dive more deeper into this subject or topic. Oh wow. Okay, I'm not going to go any deeper for now with this. I want to continue. Okay, I will define decision variables. And we want what do we want? Find minimal total cost duration. Duration. So we can say like xyz equals 1 if machine I execute task G and otherwise 0. Otherwise this. And we can say CYG equals the amount cost duration of machine Y for task G execution. This means amount, a certain amount. So in this case, example. Let's say C32. What is C32? If we look at Like the tree is for machine tree, and task well, okay. There are two numbers. Well, I can just add a comma, but I think this is okay for now. Otherwise, if this says 32, I would add a comma or a dot comma and enter another number. But for now, this is okay, and I think this is understandable what this means. If not, I can try to explain more. I think I can add more, just in case. Just give some examples. C32. If we look at 3, this is for machine, and 2 is for task. So if we look at the table, machine 3 and task 2, that is like this, and this overlaps. So this means this is 21. Machine 1, task 1, this means this is a duration of 10 minutes. Machine 1, task 3, that means this is 6 minutes. Just to clarify, this is a machine 1, machine 2, machine 3, and this is task 1, task 2, task 3. Just in case. Okay, C21, or what am I saying? C2, oh my god. The cost duration of machine 2 of task 1 is a dash. But what does this mean? I will leave it as this intentionally. When I'm going to make a formula for this, I will explain what this means. But for now, this is just a dash. Now, the cost duration of machine 2, task 2, is 20. Okay. Yeah. I think this is clear. I think. Again, if you have questions, comment them, or write something, post it in Imgur, and send it in the comments, and I will react on it such that I can help you. And yeah. Okay. I will make a formula. I will just say Z. Z is, I will define Z as the minimal total cost duration. I think I can do this better. Minimal of Z equals C1 1 x 1 1, I think. So what am I doing is I will add this all up, but like for example, if machine 1 does task 1, then we add up 10 to minimum of z. If machine 2 does task 2, we add that up to minimum of z, because machine 1 does task 1, machine 2 does task 2, and maybe, who knows, machine 3 does task 1 too. If we ignore the restrictions for now, let's say machine 3 and machine 1 does both of task 1, then we add 10 and 14 up. But if machine 1 does not do task 3, we do not add this up. So that's why I have like this kind of structure, a way of doing this, I think. I noticed that this kind of a weird thing, like for example, this is 10 and this is either 0 or 1. If this is 1, then this means this is 10. If this is 0, then this one is 0. I kind of want to reverse this. If I do this, no, I like it more with this. Oh, with this looks much better. It's more appearance or preference. Yeah. If we do this for all of them, like this, C21 x21, C22 x22, C23 x23, C31 x31 plus C32 x32 plus C33 x33. But we can do this whole thing much easier, or we can simplify this. Not necessarily simplify. We can express this in a much more compact way, and that is like this. I will say this. CIG XIG. Oh. And yes, so basically this whole thing is the same as this. Yeah. This is kind of a bit weird of a bit of a weird tree. I say I said tree a lot, which is a bit weird. Wait. Okay, this looks much better. Yes. Okay. We have formulated the minimum of C, which represents the minimal total cost duration. I will make another image, otherwise it will be a bit too much on one image with many layers or that kind of stuff. Okay, that is red. Wrong color. I think let's do this. Wait. This looks also nice. Yes. Okay. Okay, so what does this mean? Wait, I need those restrictions to explain this. Wait. Oh. Okay, I'm back to ChatGPT, and I think this explains a bit much better. So I will just read this, and maybe I will add to this. It probably says a lot, so yeah. Okay, forbidden assignments must be encoded. What is encoded? Okay, for example, machine 1 can do task 2. If you leave those entries as 0 instead of infinity, or otherwise forget the constraint, the solver may assign them incorrectly. Typical ways to encode: set cost equals set cost equals a very large number, big M, or explicitly disallow with a constraint x, y, g equals 0. Yeah, so you can either do the big M, which is just a big number or very large number, or use this. What does this mean? Machine 1 for task 1, machine Y for task G will not execute, which is also this. And so the other thing that we also can do instead of this is to set a large number for those dashes. So if I go back, oh wait, what? Wait, if I go back again, I press Ctrl Shift dot dash. I press Ctrl Shift, comma dot, and it copied something on my clipboard. Okay, I will go back to this. It's kind of distracting, to be honest. So for this, you can also say just M, a big number. For example, a big number, a million or 1,000 is big enough, I think. And yeah, By those numbers, this will be handy for later, especially the Hungarian methods, to solve what the minimum z is. So let me see. I will copy this layer. How can I do this? Wait. If I paste it like this, I will do this and transform, or maybe crop. Wait. This is a bit new for me, so please bear with me. How do I do this? Yes, okay. Wait, what? I did it almost. And if I press this, okay. This is much better. LP formulation. And z equals, or minimum z, I can say this. Yeah, so we have this. Now the restrictions. So basically this equal this my speech. These are the decision variables. Decision variables. This equal this is the what's called the objective. Wait, I don't know how it is called in the how it's called in English. I see objective, but yeah, I guess objective. Bit silly. In het Nederlands, it's called. Wait, what? In Dutch or Nederlands, however you want to call it, it's called doelfunctie. If you translate this, it's called function in English, and this is called an objective. But in English, it's just called objective for this. which is okay. I'm going to cheat a little bit by looking at the answers of ChatGPT. I can show it. I mean, there's no harm to this. It's just a practice. So yeah, it says subject to. What does this mean? Subject to a topic to this I'm going to think about this. What does this mean? Oh wait, usually it says such that or such to. What does this mean? I don't know. Wait, can I ask this? I don't know. Wait. Okay, I can ask. I thought my limit is all over or something. In optimization, subject to means under the following conditions or constraints. It introduces the constraints that the decision variables must satisfy. Formally, it's short for subject to the constraints that. Example, we write this. It reads as minimize the total cost subject to, meaning under the meaning under the restrictions that each task is assigned once, each machine has limited capacity, and forbidden assignments are 0. The forbidden assignments which are 0 are these. Oh, can I? Oh well. These are the forbidden assignments which are selected in blue. This is the minimum. Oh, okay, this is kind of annoying. The minimum, and then this blue selected is the total cost. Then we have 2 other restrictions or constraints, which are the limited capacity, and each task is assigned once, not twice or thrice or less, just once. Which is like the task assignment that needs to assigned once is this, and the limited capacity is this one. No, only this part is the limited capacity, and this is the sign restriction, like the binary thing. It can either be 0 or 1, not anything else, or it cannot be 0 and 1. It can only be 0 or 1, not both. In plain English, subject to is under the condition that Here are some synonyms with the restriction that, provided that, given that. Everyday example: find the cheapest flight to Paris subject to leaving before 9 a.m. Meaning you can only consider flights that leave before 9 a.m. So in your assignment formulations, subject to just introduces the list of constraints that your decision variables must obey. Yeah. Yeah, so to keep it simple, I would look at this as this, with the restriction that, or given that there are these restrictions or constraints, however you want to say it. And yeah. Also, another interesting thing that I also want to know: what is the difference? What is the difference between constraints and restrictions? Are they 100% the same? Excellent question and subtle. They are very closely related, but not 100% identical in meaning or usage, especially in formal optimization or engineering context. Let's unpack it clearly. 1. In everyday English, constraint equals, or constraints means something that limits what you can do. Restriction means something that prohibits certain actions. Okay, something that limits what you can do, something that prohibits certain actions. Do and actions, they overlap, but constraint usually sounds mathematical, technical, while restriction sounds rule-based or prohibitive. The budget is a constraint. It limits spending but doesn't forbid everything. There's a restriction on alcohol sales. It's a rule that forbids certain actions. Yeah, okay. Constraints more mathematical, and this more probably general. In optimization and modeling, they are almost interchangeable, but constraint is the standard technical term. Constraint, a mathematical condition that limits the feasible region, written as equations or inequalities. Example: x1 plus x2 is less or equal to 10. This is a constraint. It constrains possible values of x1 and x2. Yeah, so basically if it is 100, that means this needs to be minus 90 or even lower, as an example, to satisfy this inequality. Restriction, conceptually the same but used more loosely. Yeah, so I had a suspicion while I was reading this line, that this is like that this word is more general and constraint is more mathematical or technical. Often refers to forbidden assignments or logical rules that can't easily be expressed as a simple equation. Example: machine 1 cannot do test 2. That's a restriction which we model as x1 to equals 0. Yeah. So in a model, constraint means the formal mathematical expression like this. Restriction means something. Restriction means sometimes used for qualitative prohibitions. Qualitative prohibitions or conditions that are then converted into constraints. Interesting. Summary table aspect common in math optimization programming, everyday rules, policies, nature, formal mathematical limits, prohibitions, prohibitions, logical rule, often described in words. Oh wait, I'm already going through this. Okay, express as equations, inequality, and for restriction, often described in words, can't, must not. Here are some examples. Okay, yeah. Bottom line, in operation research, we nearly always say constraints. You can think of restrictions as the real world rules that you translate into constraints when you build your mathematical model. Would you like me to show how to express restrictions in your assignment problem, like machine 1 can do task 2, or are formally turned into constraints in the ILP form? If you're wondering, ILP is in this case is just added an I, which means integer, and yeah. Yeah, I'm going to search up what LP means real quick. Wait. It's already It's already more than 15 minutes into the recording. I mean, there's a lot of things that I learned, like constraints, restrictions, the way on writing this like this, like how to do this step by step, which is also nice. I'm going to search on Google, or I mean Firefox, Google Firefox, I don't know, ILP, meaning operation research. Yes, okay. Oh, that was kind of loud. Transition. Yeah, so LP or ILP stands for integer linear programming. a mathematical optimization technique used in operation research where some or all decision variables are constrained to be integers. Yeah, so that is ILP or ELP, ILP, I don't know. What am I talking about? I will go back. Let's see, what did I do first in ChatGPT, or what did ChatGPT do first? So as you can see, it has machine capacities. Machine 1 can do 2 tasks at most, and the same for for machine 3, but machine 2 can only do 1 or 0. Notice that there's no restriction on that every machine needs to do at least one task. There's no restriction in this case, or in this instance. So that is nice. So there's more flexibility because there's less constraints in this instance. Later you will see more constraints, but for now let's focus on this. And yeah, I am thinking a bit. Okay, I will go back to GIMP and I will write it here too. If it reacts. Okay. So yeah, so I will write this subject to, or just this, which is also okay. I will make another layer 2. S2 SSD means subject to. Okay. I will leave it here for now. Let's see. Okay. So notice that G is for task and I is for machine. To be honest, I'm just going to copy the constraints here. Why am I doing this? I think just for memorization for me. And if I go to the other screen, then I might have to look up again, and it might save some time for later in the long run or long term. Wait, what? What is going on? Long run or term? I don't know. A bit silly. I'm a bit silly with this. Okay. So, how do I do this? Let's say if I do this, what does this mean? Machine 1 do for task 1, machine 1 does for task 2, machine 1 does for task 3. I'm going to write it as this, and yeah, this for all the x plus, and here also another plus. So for example, if I look to this needs to be equal to 1. This also needs to be equal to 1, and this also needs to be equal to 1. Why is that so? Because this is for task 1, and it needs to be once executed, not twice, not thrice, or more or less, just once. So that means this if x11 is 1, then this needs to be 0 and this needs to be also 0 to satisfy the constraint. So that is what I'm going to do, which means that x11, x21, 21, x31 is 1, x12, x22, and x32 equals 1. And the last constraint for the task assignment that needs to be 1 is this one. 1. Too many ones that I say. Yeah, so this can be more compact. In this case, let's use the summation, and what we see, if you look at one thing like this, we see the first index, that is in this case the machine 1, machine 2, machine 3. We use this, and think this. Yes. So if we say this for G equals 1, 2, or 3. I think I might made it more difficult. Yeah, so if I say this is the same as this, also this, and if I change this to 2, then it means that it is the same as this, which is also the same as this. And if I change this to 3, then I take this, and which is also the same as this. So we need 3 summations, and in this case I will just do this 1, 2, and 3. And that needs to be equal to 1. This whole thing is the same as this whole thing, the whole 3 constraints, which is also sort of this. This is just a whole thing. Okay, I'm not going to make it more confusing. That's not my point. Is it reacting this? I can't move. What? Okay, what's going on? Misschien V, M, P, this is a bit annoying. Oh, wait. Can I? No, please. Okay, I can zoom in, zoom out to move. I think it is something to do with my graphic tablet, which is a bit annoying. Wait, if I do this. Okay, that is interesting. I want to clear this up. This is taking a lot of space. What is this? If I can select this and copy this as a separate layer, then that will be nice. Nice. What is going on? What about this? No, wait. maybe I shall duplicate this. I'm going to think for a moment, or maybe no, I'm just going to take a break for now, and I will take some time what's going on, and yeah, so I will just take a break, take some time figuring out what's going on, and yeah, I will be back later. Okay, break time. Okay. So I am back. I kind of forgot what I talked about. Like at the end of the last recording, like I said something about figuring out and break time. Well, I did my break. Oh yeah, I know. So my mouse did not really react to the image like this. Yes, it's now not doing anything. Now it does. To be honest, I don't know why it's doing that. I ended recording and it just immediately worked. How? I don't know. Maybe I went to my auto screen and then it reacted to the image. So it's kind of weird. I'm not going to focus on that problem. So I will continue with this. Okay. I organized the layers. So here's the decision variables. As you can see, it's visible and invisible. This kind of a bit of a weird thing. It's just basically this. Wise partial. The decision variables is also a part of the formulation, and also the constraints are a part of the LP formulation. So that's why I said partial and not a whole. So it's more a bit of a better description, especially on how much I can write in this. I can make it more descriptable, more descriptive, but it will but I have to do this. That is not really that I like. I like to have more screen for my image to write on, so that's why I kept it short. Partial LP formulation, or ILP probably. Then I have this layer. That's just this. That's my explanation about the constraint of that each task has to be assigned once. And at last I have this, the blue thing. ST means subject to, and that's all. Basically, I only need this layers, these three, and these are extra, so I won't have to worry a lot with these two. And yeah, it is better organized, and I will continue. So I will add another layer. I will call this task assigned once constraint. Hopefully this is not a long name. Oh, it is. Okay. Maybe this constraint. Yes, that's much better. I will zoom in and I will add the constraint. It was a summation e or I equals 1, and it goes to 3. There are 3 machines. For each task it needs to be assigned once, and for G equals 1, 2 or 3. Wait. Okay, I use my mouse, I clicked on the other screen and back to this, and I can use my mouse again, so that is kinda nice to know. I will do this. This means that this is constraint 1. There will be more constraints. The other thing is we have talked about how many tasks a machine can do. We call this a capacity for the machine, of capability, capacity. For I will say it on a easy way. I'm going to say it in a simplistic way. I will say it is a capacity, I think. I have to think about this because I'm just saying stuff without thinking, which is not very good. So a machine can execute a task, and how many tasks it can execute, we call this in ChatGPT it says capacity, which is okay, but maybe there's another word for it. A room for machine to execute, room, space, machine space, space for machines to execute, storage, yeah, I think capacity is like a better way or a simple way to say it. I wonder what ChatGPT says about this. Like, I've copied this. How do I call something like the room or space for machines to execute? For example, machine 1 can execute 2 tasks at most. You said capacity, but maybe there is a better word for it. Yeah, I will prompt it like this. I wonder what it's going to say. Excellent linguistic and modeling question, and you are right to notice that there are a few possible terms depending on the context you want to emphasize. Let's look at the subtle differences. The most common and precise term, capacity. Machine 1 has a capacity of 2 tasks. Why it fits? Capacity in operation research (OR) means the maximum workload or number of jobs a resource can handle. It's the standard term in scheduling, assignment, and resource allocation models. So if you write each machine has a task capacity, machine 1 and 3 can handle at most 2 tasks, machine 2 at most 1. That's perfectly correct and professional. Alternatives, depending on what you want to emphasize. Capacity, standard in OR limits how much a resource can process. Machine 1 has a capacity of 2 tasks. Availability, when referring to time or uptime, window rather than quantity. Machine 1 has 8 hours of availability per shift. Throughput limit, when referring to processing rates, for example task per hour. This line's throughput limit is 5 jobs per hour. Slot or processing slot, when you treat each machine task pair as a discrete space. Machine 1 has 2 processing slots. Load capacity, slightly more physical, used in logistics, production. The CNC machine's load capacity is 2 jobs per batch. Execution window or workspace, more literal, used if you are talking about physical or temporal space. There are 2 execution windows available for machine 1. Yeah, okay. So basically it depends on context and I don't have any in this case. In mathematical models, if your constraint is this, then the phrase is machine 1's capacity constraint allows at most 2 tasks. That's the textbook phrasing in OR, scheduling and linear programming. Summary recommendations, goal, best term. Yeah, execution, is it physical, virtual, time-based? Interesting. A bit of a side note, as you can see or hear, I mean, my voice is getting a bit rough. Usually I don't speak much. It's like 40 minutes into the recording. This is a separate recording. It's still the same day as the previous one. A bit weird to say this, but now you got more context about me, which is okay. I don't mind with this. So yeah. Okay, what does this say? So your sentence called B. Each machine has a limited processing capacity. Machine 1 and 2 Machine 1 and 3 can process up to 2 tasks and machine 2 up to 1. That's exactly how a professional OR paper or report would phrase it. Would you like me to show how this capacity ID is formally written as a capacity constraint in your assignment model, like in ILP or LP notation? No thanks, this is okay. So these are the alternatives depending on the context or what you want to emphasize, like what you want to give attention to. And yeah. There's so much stuff. Practically it is like more simple than this. This is more like really in-depth stuff. Okay. So basically this is the machine capacity constraint. Like what is going on? There's like 4 tasks, 1, 2 and 3. Wait, no. So what is this? What is this constraint? Okay, stop with the Ask ChatGPT. So this, what I'm selecting, I'm going to say what is going on. This is machine 1, and machine 1 can do 1, 2, 3, and like X can be 0 or 1. So machine 1 can do 2 tasks at most, and it can choose 1, 2 or 1, 3 or 2, 3. So there are 3 possible ways that this can be true, and that's not really correct. Wait, no, stop, not, don't ask. I will go back to GIMP. Oh wait, I was with this layer. Explanation. Wait, I will say this: machine capacity explanation. So we saw this. So what does this mean? This means I will write this to here, which is the same as this. And the only way this can be false if every task of machine 1 is no. This can be true if this is 1, this is also 1, and this is also 1. So every tree must be 1 to this satisfy this constraint. So there are multiple ways to make this true and one false, which are this. Yes, so there are 7 possible ways to make this true, and I will use this. And this one is false. So there are, I think, 8 possible 8 possible ways to go with this inequality. Since there are 3 variables, 2 to the power of 3 is 8. So you know, wait, why is this? Why am I using 2 to the power of 3? Well, this variable, decision variable, is binary, so it can be 0 or 1, which are two ways, 0 and 1. And if I use 3 variables, then I can use this kind of formula. To be honest, I'm not really I don't really know exactly how this works, like in other situations. Like, I read it a lot, but I don't know how to apply it in many situations. So I know that's kind of a annoying problem. But this is also another way to find out. There are 8 possible ways to see what outcomes there are, and what each what in each individual variable has, or combination, or permutation. No, I think this is a combination problem instance. Yeah. So that's kind of interesting. I will add it here. Wait, I have to make another one. Constraints. This time, wait. Yes, I can move again. I will add it here. I think it's also kind of important to know what each constraint is, or Since it's already labeled like this, you know what, I'm going to do it anyways to make it more clear. I'm going to use the ChatGPT description, which I think is fine for this. Each task assigned once. If I do this, I'm going to place it here, and I will write the machine capacity constraint. I'm going to make it little because I need more room. Oh. Oh, I forgot something. There's a high chance that I'm going to take another break. It's a special day for me, so I know, a bit annoying to stop. Okay, I call this I have labeled these three constraints as 2, and for each, this is for task 1, task 2, task 3. So I'm going to write this machine 1. Wait, no, this for each machine, not task. Machine 1. Okay, this is going to be a bit weird. Machine 1 can do at most 2 tasks. Machine 2 can do at most 1 task. Machine 3 can do at most 2 tasks. Okay, Okay, this looks nice. Then I can show you this. There are forbidden assignments, such as machine 1 can't do task 2, so this will be automatically 0. And machine 2 can't do task 1, machine 3 cannot do task 3. So this is why these decision variables are equal to 0. And again, x1, what am I saying? X, y, z is either 0 or 1, not both. And yeah, I'm going to write this also in GIMP. And yeah. How am I going to say this? I have forbidden assignment constraint, which is a bit too long. Forbidden enable what is a good word? Machine no assignment constraint. I think this is okay for now. I will write it as this. Which means machine 1 cannot execute task 2. Machine 2 cannot execute task 1, and machine 3 cannot execute task 3. Then the sign restriction or constraint, not that, oops, which is x, y, z, either 0 or 1. And to finish this up, y equals 1, 2, 3, and z 1, 2, 3. Yes. So this is the fuel, the whole thing of the LP formulation. I could say oh, to make it more accurate, I'll say it like this. And this is the full ILP formulation, integer linear programming formulation. What is kind of missing is the CIG values, which is this. And so the CIG values in this case for the dashes is just a big M, a big large number. Like here's M, here also, and the rest are just like given. Like the C11 is 10, C13 is 6, C22 is 20, and it goes on. And yeah, I will add this to make it more complete. Sign constraint. Oh, that is not good. Come up, come on. Yes. Okay. Yes, I'm going to take another break. It's a lot. Let's see. Wait. Before I take a break, as you can see, it says the cost matrix, and yeah. Okay, I will take a break, and I don't know, to be honest. I will take a break, and take some time for me to organize my thoughts, which are essential for this. Otherwise I will go into loops, and that is not what I want. Yes. Okay, I'm going to take a break, and I will explain more later. Oh. Hello, I'm back. This is a other day. I took quite a long break. I can show you the time and date. It's 27 October 2025, and it is 12 p.m. So it's like midday. And yeah, why did I took a long break? Well, this video is quite like it takes a lot of energy for me, and I don't want to make myself I don't want to make myself too burnt out. I don't think burnt out. I don't think this is the right word to say this, but I don't want to waste my energy too much. Although this is not like energy wasting. I don't know. It just takes a lot of energy. That's all. So yeah, I'm back. I'm going to see what I did. So it's about the continuation of the LP or ILP problem that I did from another video. And yeah, as you can see, I did the ILP formulation. I'm kind of proud of this, which is okay-ish, to feel that way. And yeah, okay, I will continue with the ChatGPT thing. As you can see, we already talked about this. You can see the CIG value where the machine can't execute a certain task is set to infinity. You can use large M, just this, which means just a large enough integer value or number, and which what does that mean? It means that this will be large, but we want to find the minimum, and by doing this we try to avoid to let the machine execute this certain task, in this case task 2. So yeah, I'm just going to read this, like what's going on. I haven't really done this. I mean, I have done this reading, but for you guys or girls, whoever is watching, I'm going to read and you can just listen. I don't want to waste too much time. Okay, solve it, explicit enumeration, reasoning. Like the emphasis on reasoning. Feasible assignment, choices, respecting forbidden pairs and capacities were checked. The best feasible assignment is task 1 is for machine 1, task 2 is for machine 2, task 3 is for machine 1. And if you add this up, you will get 36 minutes, and that's the minimum. Using this ILP formulation, or using this these constraints. That assignment respects capacities. Machine 1 has task 2. Remember, machine 1 can do 2 tasks at most. Machine 2 has 1 task, can do 1 task at most, and machine 3 has 0 tasks. And again, machine 3 can do at most 2 tasks. So yeah, we see that machine 1 has 2 tasks. Machine 1 does task 1 and task 3. Okay, notes or alternatives. If you want to apply the Hungarian algorithm, replicate machine with capacity greater than 1. For example, replicate machine 1 into 2 identical rows, M1A, M1B. Yeah, okay. which is also good. Like M1 probably means machine 1, and you have 2 rows for machine 1, and I guess this is a way to identify their rows. Again, for machine 3 it's kind of the same idea, and machine 2 just 1 row. It can do at most 1 row, 1 task, and then run Hungarian on the 5x3 rectangular problem. You will need to pad the square matrix that will produce the small optimal result. This is not a square, so we have to add artificial tasks to do the Hungarian algorithm. If you accidentally treat forbidden accidents as 0 cost, you will likely get wrong answers. Because solver prefers 0, use infinity for disable those variables. Realistically, why do I say large M? If you program, this is not really a number. Use large M such that you can make the algorithm in Excel, Python, I don't know. I haven't done this, so this is just my thoughts. And okay, I have to stop making too much conclusions, which is not very good. So what does this say? If you want, I can show the small enumeration I used step by step, or produce a short Python MIP script, or replicated row Hungarian conversion so you can run it yourself. Which would you prefer? I'm just going to ask what enumeration means and what is MIP. What is enumeration? And what is Python MIP script? Great, you are touching 2 key ideas from optimization and algorithm design. Enumeration and Python MIP mixed integer programming script. Okay. That's quite interesting. So it does not explicitly say it's linear. Let's explain both clearly with examples tied to your assignment problem. Enumeration in operation research definition. Enumeration means systematically listing and checking all possible solutions one by one until you find the best optimal one. In other words, you try every feasible combination, compute its total cost, and pick the smallest or largest value. Example, your assignment problem have 3 machine and 3 tasks. Each machine must do 1 task. That's a permutation problem. Okay. There are factorial of 3 equals 6, like 1 times 2 times 3 equals 6. Since 3 tasks can be arranged in 6 ways, if you list all 6 possible assignments, compute the total cost for each and choose the smallest, that's enumeration. Yeah, okay. Just for clarification, M1 means that machine 1 and T3 means task 3. So in this case, machine 1 is assigned with task 3. Okay, enumeration finds that the minimum cost equals 40. Pros and cons. Pros, simple and guaranteed to find the global optimum, easy to code for small cases. Cons, grows exponentially, very slow for large problems, not practical for many machines/tasks. When used, teaching, demonstration, small assigned problems, checking correctness of an algorithm, like comparing to Hungarian results, benchmarking optimization solvers. Yeah, okay, so this is just for enumeration. Okay, I talk way too fast. Python MIP, with MIP is this. It's a Python library for building and solving linear and integer optimization problem using solvers like CBC, Gurobi, and or CPPlex. Yeah, so what is MIP? MIP stands for Mixed Integer Programming, meaning a model with some variables, decision variables, restricted to integers, or 0, 1 for binary decisions. So not all variables are binary, which means this is more mixed. Yeah, I think so, yes. If it's not 0 or 1, then you have like you introduce decimals and greater or less than 0 or 1, I think. Yeah, it's a modern programmable way to solve problems like the one you are studying. Maybe there are more Python libraries for MIPs. Yeah, so this is just a Python code. I will skip this because I don't want to emphasize on this. Who knows, maybe I will do later one in the future. I won't promise this, but it's nice to know this exists. Okay, yeah, I will leave this. You can read this if you want, but I don't think this is important. I feel like it's not important, not think. I feel like it. Okay. I will go up. There's so much. So I ask a question. Why is this 0 and not infinity? Again, those x decision variables are either 0 or 1, like whether a machine will execute or not. So it's 0 or 1. And when will you use infinity or large M? It's for the C decision variables. Decision? I think it's just a variable. Or a it's called, it's a parameter like this, or more precisely this, like the ing are indexes. So a weird notation, but yeah. Yeah, so CIG is just a parameter. Maybe I will make a video what a parameter means. And yeah, I will, yes, I will set this in a notepad for later. Make a video about parameter. Yes. Um. I think ChatGPT is just saying this. A common. Is it really common? I don't know. Like, how do we know if it's common? Okay. I'm not going to. I have to stop ranting or venting. I don't know. The difference between 0 or equals infinity in modeling. There are two distinct ways to represent forbidden assignments in an optimization model. There are two approaches, constraint-based and penalty-based. And wait, yeah, so this sort of approaches, and then you have like this. Okay. What do I do? If it's a constraint based, explicitly fix the decision variable to 0, xyg equals 0. And if it's penalty based, keep the variable, actually it's a parameter, keep the variable but give it a huge cost, cig equals m, where m equals a big number, for example million. What's the meaning for this? This means machine I is not allowed to do task G. The variable is removed from the feasible set. It's as if that option does not exist. This discourages but does not forbid the solver from choosing it. It will only pick it if absolutely necessary, for example to avoid infeasibility. Yeah, I would assume this does not exist. If it exists from the like if the solver, or if you try to solve the the instance and it gives a assignment with this, then there's something wrong, or it gives you a infeasible solution. So yeah, I would keep an eye on this if you get a solution from with this, if that makes sense. I could try to explain it on this, like oh, I don't know if you can hear this, but it's raining outside. The heck? Yeah, okay. Oh no. My microphone was not on. I tried. I don't know. I will stop the recording. I kinda feel devastated. Devastated? I don't know. This sucks. My microphone was not on. I spent 1 hour on explaining this. Okay. I will stop. I tried. I showed some stuff. Or all of them. I don't know. Okay. Yeah, so I will try to repeat what I said. Who knows? Maybe in the future I will make this video, but more compact and more valuable to watch. This video was more for my mind, like how does my mind work, like realization and comprehension in real time. But this kind of failed, I think. It kind of failed and it did not fail in some ways. I don't know. I have to look up a bit in this video. But it really sucks that my microphone was off the whole time, 1 hour long. I hope some of the stuff are on, like the audio is on. Well, at least my conclusion is here. You can see it. Like, what do I have to look up for, realize, and yeah, it sucks. Okay, I will end the recording here. Bye bye.